guys, welcome back to my YouTube channel, and today I'm up with the next question of top 150 interview questions of lead code. So let's get started with the same. It's also based on the approach of two-pointer. So let's discuss the question and then move further. So the question is subsequence. So we are given two strings. We have to return true if t if else is subsequence of t, otherwise we need to return false. So what is the meaning of subsequence as a whole? What we can say is that a string, like suppose I have a string, let's take the example that we are already given. We are given ABC, and then we are given a string T, which is AHBGDC. GDC, yeah, that's correct. So for S to be substring of T, so there must exist characters of S in T in such a way, like if I try to remove S, H, J and A, so this order of sequence, the sequence of occurrence of these characters A, B, C in the string T remains the same as in the S. So a pretty simple question. So I think uh, not a very hard and fast type. We can simply do it using AHBGDC. Simply do it using a two-pointer approach. So the two-pointer here over says, like, first of all, for S to be a substring subsequence of T, the basic condition that it exists is that the length of S should be should always be less than or equal to the length of T. This is the base case that I can actually think of over here. So the edge case, I guess, for this problem exists that whenever my S dot length, like the length of the substring, length of the string S is greater than the length of the string, we must always return false. So answer to this case is false. Why so? Because because if there are the number of characters existing in S are more than the number of characters existing in T, then we cannot say that S is substring or S is subsequence of T. So the first condition that we need to satisfy over here is that we need to ensure that the length of string S is always less than or equal to the length of T. So now let's take a pointer J, alright, and initialize it to 0. So let's discuss the algorithm directly. Take a pointer J, initialize it to 0. So what I will actually do, I'll simply compare the length of this S with this of T. So I take one pointer I over here, I take one pointer J over here. So whenever my jth character, that is the first character of S, is equal to, so whenever the jth character is equal to the ith character, I will simply increment my J. So what is actually J signifying over here is the pointer at which it's standing over here. So I'll simply take a pointer J and I'll simply take a pointer I over here for string T. So whenever my I equals J, I'll simply increment my J. Okay, and I will be incremented because we need to traverse the whole string T in order to find the subsequence of S. So fair enough. So I have incremented my J, I have incremented my I. So is I equal to J? No. So I'll increment my I again. So is I equal to J? Yes, it is. So I'll increment my J. My J has become 2. and now my j has reached over here. So, and I'll increment my I as well. So, is I equal to j? No. So, I'll increment my I only, not j. So, is I equal to j? No. Again, not the case. So, is I e incrementing I? So, is I equal to j? Yes, it is. So, my j gets incremented to 3. So after doing this two pointer approach, what we need to check at the end. So what is my last so what is the result that I must have? I must have a result that my subsequence exists in the string T. So what I will do? So what is actually J? So J is actually the length of S. So at the end of the result, what I will do, I'll simply compare my J with the S length. If it's equal, it means I will be returning a true, otherwise it's a false. So, mm, so there might be a doubt in the viewer's mind that why I'm just returning the result of this condition, because the condition with which I'm moving forward my j pointer is that if my j is equal to, if my t of j, oh sorry, s of j is equal to t of I, then only I am incrementing my pointer, otherwise I'm not incrementing it. If this condition holds true, then only my j gets incremented. That's what the uh, that's what the theme of this question is. So the time complexity involved over here is big O of n. Space complexity is big O of 1 because we are not storing anything in another string. So now let's discuss the code for the same. And I've already seen, I've already told you that this is the possible code that we have, but I've not covered the the edge case over here. So I can even check that if my s1 is greater than s2, like my string s is greater than my t string, so I'll simply return a false over there. So no issues. So now let's run the code. It's working fine. Let's submit it. And yeah, it's working well. So that's all guys for today's question. So I hope this question helps you a lot. And if it helps, if you've understood the concept, please do hit the like and subscribe button. Subscribe if you are new to the channel, and like if you are already a subscriber. And if you feel that I have explained it very, very well, so please do share this video with your friends so that it may help them out. And thank you guys, and keep watching my videos.